In this video, we're going to talk about how to solve a utility maximization problem where a corner point solution occurs. Colton has $8 to spend on his two favorite types of candy, Twizzlers and gummy bears. His utility function is given by the following: T times G plus 10T, where T is packs of Twizzlers and G is packs of gummy bears. Each pack of Twizzlers costs $1 and each pack of gummy bears costs $2. Our goal is to solve for Colton's utility maximizing basket. What do we need to know in order to solve this question? We need to know the utility function, the price of each good, and the consumer's income. How are we going to solve this question? We're going to start out by using that tangency condition where the ratio of marginal utilities is equal to the ratio of prices. And then we're also going to use the budget constraint where the expenditure on Twizzlers and gummy bears has to equal income. We also need to talk about what happens if things go wrong and one of our optimal values is negative. If this is the case and we find that T is a negative value, so the amount of Twizzlers is some negative value, then we're going to conclude that Colton here is not going to buy any Twizzlers. T is equal to 0. And his consumption of gummy bears is going to be as much as he can afford, I over the price of gummy bears. If instead we find that G is negative when we use our tangency and budget constraint method, then we're going to conclude that Twizzlers is equal to I over the price of Twizzlers, so he's going to spend all of his available income on Twizzlers, and G is equal to 0. So the conclusion here is, if you engage in a sort of standard utility maximizing process and you solve and find that one of your values is negative, you need to reevaluate the question and say that negative value is sending me a signal that that consumer is not going to buy any of that good, and they're going to spend all of their available income on the other good. Let's solve this question. We know the utility function, the prices of both goods, and Colton's income. We know that we are looking to find Colton's utility maximizing basket. So we're going to proceed as if we do not suspect a problem, meaning we're going to set up the tangency condition and the budget constraint. So to do that, we need to start by computing the marginal utilities. The marginal utility of T is the partial derivative of the utility function with respect to T, which is going to be G plus 10. The marginal utility of G is the partial derivative of the utility function with respect to G, which will be T. Using those two marginal utilities, we can set up the tangency condition. So it will be the marginal utility of T divided by the marginal utility of G is equal to the price of T, which is $1, over the price of G, which is $2. I'm going to call this equation 1. We're going to take this and we're going to combine it with our budget constraint. And the budget constraint here is the price of T times T plus the price of G times G is equal to the income of $8. I'll call this equation 2. So we have two equations and we have two unknowns. From here, I'm going to take equation 1, that tangency condition, and I'm going to solve it for how T depends on G. This is a simple sort of cross multiplication exercise. I have T is equal to 2 times G plus 10, and then simplifying gets me 2 is equal to 2G plus 20. And I'll call that equation 3. Now what I'm going to do is I'm going to take equation 3 and I'm going to substitute it into the budget constraint, equation 2. And by doing that, I'll be able to solve for G. So in place of T, I put 2G plus 20 plus 2G is equal to 8. Now I'm going to collect my G's together. There are 4 of them. So I have 4G is equal to 8 minus 20. I hope you see the problem that's starting to appear. 8 minus 20 is equal to negative 12. So G is equal to negative 12 divided by 4, which is negative 3. I'm going to call this equation 4. I'm now going to proceed as if I don't suspect anything is wrong. So we're going to take equation 4, that G is equal to negative 3, and we're going to substitute it into equation 3 and solve for T. So T is equal to 2 times negative 3 plus 20. So that's 20 minus 6, and 20 minus 6 is 14. So under the assumption that G is negative 3, T is 14. Now, obviously this is not the correct solution. Let's talk about why. Well, a negative value has an implication here that Colton is actually selling gummy bears. And Colton doesn't have 3 packages of gummy bears to sell. And because he doesn't have 3 packages of gummy bears to sell, he actually can't afford 14 packages of Twizzlers. And we can see that really clearly. A Twizzler costs $1. He has $8. The most Twizzlers he can buy is 8. The only reason the math is telling us he can buy 14 is because it's making this really strange assumption that we're selling 3 gummy bear packages for $2 each. So Colton has amassed $6 of extra income. And with that $6 from his gummy bear sales, he's able to afford what he really wants, which is 14 packages of Twizzlers. So what's happening here is our tangency condition is in the wrong quadrant. And when we have that solution, we have to reevaluate. We know that G cannot actually be negative 3 because Colton isn't holding any gummy bears that he can sell for extra cash. So we're going to figure out what the actual solution is now that we've thrown out what the tangency condition has revealed to us. We draw a conclusion. We observe G is a negative value. That sends us a signal. It says Colton is not going to buy any gummy bears. So he's going to spend all of his available income on Twizzlers. And if he spends all of his available income on Twizzlers, it's really easy to figure out how many Twizzlers he can afford. He has income of 8 divided by the price of Twizzlers, which is $1. So he's going to buy 8 Twizzlers. And he's going to buy 0 gummy bears. So if you're ever solving a problem using the tangency and the budget constraint method and you encounter a negative value, that doesn't necessarily mean you've made a mathematical mistake. It means that the tangency between the indifference curve and the budget constraint exists in the wrong quadrant. And you have to sort of push the math away and use your economic logic to proceed. A negative value means 0 consumption of that good and all available funds used to purchase the other good.